Hi guys, welcome back to the channel. Today we'll try to implement automation with bash scripting. Well, to understand what bash is, bash stands for Born Again Shell. This is a command line interpreter which is used across Linux and Unix based systems as it allows users to execute commands interactively or store them in scripts for automation. A bash script essentially is a text file which contains a set of unique sequences of commands which basically are executed in a specific order. Automation in bash basically allows us to turn certain repetitive tasks to be executed without manual intervention. This would allow us to reduce human error and increase efficiency. So here we basically end up saving a lot of time, basically perform routine administrative tasks, ensure consistency, reduce errors, or schedule cron jobs which basically are executed periodically. Basic components of a bash script basically start off with the shebang, which basically allows us to define the shell interpreter for the purposes of executing the said script, followed by different aspects such as variables, conditional statements, loops and functions and more. In order to set up our first bash script, we will basically go ahead and create our script, something like demo.sh, and hit enter. Once you perform ls, you will see that our empty shell file has been created. So let's just open this script. We're going to import our bin bash to define our interpreter. You can also use Vim or Nano. Nano is a little bit more beginner friendly, so it is suggested and it is up to you. Let's say we want to send out a specific message like echo hello. This is my first script. Let's say listing files in the current directory. We can write ls-lh. Here we basically have defined two echo statements which would print this text into the terminal, while ls-h would basically list out the contents of the directory. Here we have defined a flag called -l and h, where -l basically enables long list format, while -h would make all the sizes of the files located at a specific location human readable. Here we will press Ctrl X, press Y to hit enter to save this particular script. Moreover, it is essential that you basically add executable privileges to this specific script. For the user, you would type u+x followed by demo.sh. Here we have made it executable. We will hit demo.sh and hit enter. As you can see, we basically get an output which looks something like this, where we basically print out the first two lines of text followed by our output from ls-lh, which basically gives us the total size of the contents which are there in this present working directory. Common mistakes basically involve usually people forgetting to implement the bin bash at the very top, which might lead to unexpected behavior. Therefore, it is essential that you would implement hash and the bin bash at the very beginning of the script. Always need to ensure that your scripts are executable or on your PC. As you can see, the executable privileges have to be ordained by the user with the help of chmod. So yeah, and finally you basically go ahead and execute your file. this is the conclusion of the first part. We will now dive into automating backups with bash scripts. The second part, which involves automating backups with scripts. Whenever we encounter hardware failures, accidental deletion, cyber attacks, or system crashes, data loss is a real threat. It can happen at any moment. Therefore, requirement of backups is an essentiality. It is essential that we find a way to automate bash scripts, which basically ensure certain critical files are basically consistently and securely backed up without human intervention. Usually, backups are of three different types. Full backup basically involves a complete copy of all files being stored during the backup runtime. Meanwhile, incremental backup is a process of backing up only files that have been changed since the last backup, followed by the final version of differential backup, which backs up all the changes since the last backup was fully made. For simplicity's sake, we will basically try to copy essential files to a essential backup directory, add timestamps, or compress the backup to a safe space. Certain key commands which are essential for this purpose basically involves a cp command, which basically allows us to copy certain files from one location to other along with the property of being renamed, or sync, which basically is used for the synchronization of files, tar, which is used for the process of archiving and unarchiving files, date, which basically generates timestamps for files, mkdir, and cron. Cron is basically used for scheduling backup scripts so as to automate certain segments of scripts for execution. Let us try to write this backup script. In this scenario, we will define a source directory and a backup directory. The source directory is the folder which we want to back up, while the backup directory is the folder into which this backup would be stored. For the purposes of this, we will go ahead and create a small backup script called backup underscore script.sh. We hit enter, import our bin bash for the purposes of our interpreter. Let's define the source and backup directories. We will write source dir and backup directory. Here we will define a specific path. This could be any arbitrary location. In this scenario, I am documenting document. Let's say documents, and let's say we store this into backups. For the purposes of the timestamp, we would create a date. So here we would add date. We will define timestamp, date, and we will add the information %y plus %m %d. Here the date is going to be stored in YYMMDD format. Moreover, if we like, we can also go ahead and implement the hours, seconds, and minutes. For that, we will write %h, %m, and %s. Here we will define the backup file. Backup file equals to, we will specify the backup directory, and we will specify timestamp. tar.gz file. Here we also have to ensure that this specific directory exists, so we will specify backup directory mkdir -p, and we will specify $backup file. In this scenario we'll use mkdir. We will go ahead and create the backup. Backup file followed by the source directory, here we would also like to print a specific message. We will write echo backup created successfully at the location. Backup directory. Here it is essential that we always go back to our script to ensure that there are no typos or spelling mistakes, so we can go back and check up our files, the structure of the script. In this scenario I have already spotted a mistake. Always add spaces in regards to the date, because it's usually the command structure. Sometimes there's also a requirement to also specify, oh yeah, I forgot to mention dollar, because this is a specific not a string literal but a variable. We also need to check up whether our variable terms basically match up. In this scenario I seem to have also made the mistake of not specifying the actual variable name. Once this has been done, I think all of our errors are potential errors have been fixed. We will exit and we will write backup script.sh. Depending on the files that are located within your specified directory, it might vary. However, in this case our automated backup has worked, and you can see that this specific location and all the files within it have been successfully backed up and are available for viewing in backups. As you can see, that tar file has been created with an attempt to have a timed information as well as to be stored into the name of the file. In this segment, we will try to schedule automated backups with the help of cron jobs. Usually, we would use cron jobs in order to avoid manual backup of specific files, and usually that is pretty unpractical and tedious. Therefore, cron jobs come into play. These are Linux task schedulers which are inbuilt, which allows users like us to run scripts at specific time intervals automatically. The syntactical nature of such crons usually follows something like this. Here we basically have a scheduling parameters which are represented by asterisk symbols. Let's call them as first, second, third, fourth and fifth fields. The first field here, or the first asterisk symbol, is representative of the minute, which spans across the values spanning from 0 to 59. The second field here basically refers to the hour, which is represented in a 24-hour format spanning from 0 to 23. The third field basically refers to the day of the month spanning from 1 to 31. The fourth field refers to the month basically spanning from 1 to 12, while the fifth field refers to the day of the week. 0 stands for Sunday, and this spans from 0 to 6. So 0 is Sunday, 1 is Monday, 2 is Tuesday, and so on. Usually common cron scheduling examples usually look like this. In this case, this particular task or script that we have would run every minute, which is not something that you would like to do. Here, for example, if you would like to start this script every hour, you would specify something like 0 at the very first field, while if we wish to run it every day at 12 a.m. we would write something like this. However, if you wish to run it at Monday at 3 a.m. in the morning, you will specify something like this, where 1 basically refers at the fifth field refers to Monday, and 3 represents the hour in 24-hour format, which is 3 a.m. Let's say you wish to run it every first day of each month. You would specify something like this. So yeah, here 1 to 31, this could basically be 31 if you wish to run it at the 31st day of the month, depending on the month that you are planning to do it. So yeah, in this case, let's say we would like to add the cron job entry to run our backup underscore script.sh every day at 2 a.m. We would write our script or cron instruction in this file in this manner. Here it is essential that you also specify the full path to the script file that we wish to execute. So in this scenario, I would write my script, the length, the beginning from the root to the specific folder where I am located at, and I would also like to store the output as a log file. So here again I would have to specify the full length to a specific location. Let's say backup underscore log .txt. Here we also have to capture standard output and errors to this specific location. Let's say we just copy this selection and we basically open up the cron tab editor and paste this cron instruction. So for that we open up cron tab -e. We go to the bottom. You can see I already have a few cron jobs already running. You can paste your selection. We would like to exit, save and hit enter. As you can see, we have a message where cron tab has installed a new cron job once you have saved and exited. In order to view or verify your scheduled cron jobs, let's say we want to list all the cron jobs for the current user, you would type crontab -l and hit enter. You would see that our latest entry is visible. So yeah, that's pretty much the way we implement scheduled backups, where we have basically redirected all the logs of our backup to a specific location, and these cron jobs can be implemented for separate users and we can also delete all the backups in an automated way, and several different things can be done here. So as I would say, you can explore more and implement different types of cron jobs and see what happens. So yeah, I hope you learned something today, and I will see you in the next one. Bye.